must have come across this particular joke that's forwarded in WhatsApp, which talks about how unskilled or semi-skilled laborers make more money than B.Tech graduates in our country. You must have also read reports about the unemployability issue among B.Tech graduates, that only 17% are employable. You might have also witnessed that there is a mad rush towards other degree programs and not towards B.Tech, so that students at the end of 3 years, can pursue some government-related entrance examinations. Now, what's the truth behind this joke? And what's the reality behind these facts? We'll examine them towards the end of this video. But first, congratulations on having cleared your 12th standard examination, having completed your school education. And now the time has come to pursue college education, to make the choices and then have more self-directed, semi-independent learning in your life towards a career. And here, I am Dr. Arun Surendran, Principal and Strategic Director of Trinity College of Engineering in Trivandrum. I received my B.Tech from Indian Institute of Technology, Mumbai back in year 2000, and then I pursued my Masters and PhD at the Texas A&M University. Currently, I'm happy to be at the Trinity College campus, which was established by the visionary leadership of Dr. Thomas Alexander, so that students who come to do B.Tech are closely aligned with industry, and they get to see hands-on what goes on in the industry through the faculty-run companies on campus. So I am talking to you not just from the perspective of an educator and an engineer, but also as an entrepreneur who has engineering companies which are run on this particular campus. So with that introduction, let's dive right in to the scope, excitement, and potential of engineering education. If you look at the list of branches that the IITs have for pursuing your B.Tech degree, they are almost close to 90, including the different specializations. So without considering about all these 90 branches, let's think about those 4 branches which are considered to be core engineering or evergreen branches. We'll take a look at them one by one. They are evergreen because their potential never fades. They are evergreen because they keep for you the options open for pursuing higher studies in different areas to specialize later. Consider it something like, doing biomath in your +2, so that you can either turn into a medical profession or look towards engineering profession. Now let's take a look at one by one these core evergreen branches. Okay, so let's begin the discussion of the core engineering or evergreen branches. We'll start with mechanical engineering, and I am standing here in the production engineering lab. Now, most of us might think of engineering, the first thing that comes to our mind is building a house. That's civil engineering. And civil engineering is called civil engineering because engineering began as a military science to design weapons and construction of tools and machines right from the beginning. And that engineering branch has gone on to become mechanical engineering. Mechanical engineers also study subjects like fluid mechanics. They study automobile engineering, that comes as a part of it, material sciences, heating, ventilation, because thermal energy and its transfer are also part of mechanical engineering. So you can branch off into a wide range of subjects once you take the core engineering branch of mechanical engineering. Now, for decades in India, and especially in Kerala, mechanical engineering was considered to be a branch that was suited only for boys. Very rarely women used to enroll in mechanical engineering. Gladly that has changed, and even in Trinity College, our college, the percentage of girls who are enrolled in mechanical engineering has been steadily going up, because mechanical engineering these days is more about design and analysis of stuff around us, of machines, of building and things like that. So there lies the core engineering branch of mechanical engineering, which offers to you immense possibilities in studying about how the world operates in terms of machines. The second core engineering and evergreen branch we want to discuss is civil engineering. Of course, it's the most visible of the branches, since you see construction and building all around, especially as we are a fast developing nation. Right behind me, you will see an example of good construction going on here at Trinity College campus itself. You see, we wanted to expand our ground and put in an international artificial turf, and therefore land had to be filled, and a retaining wall construction is going on there by the workers in yellow uniform of Adrak, India. Now, civil engineering is not entirely about building plants, constructing them, or having building information management system, which is the latest technology which allows you to program and plan the entire construction even before the first brick is laid. We also have large-scale transportation, geotechnical engineering, changing landscapes themselves, and even using satellites for geospatial information system. So it's an exciting branch that involves really changing on a large scale the living spaces, including the interior spaces that we will occupy for living and working. After mechanical and civil engineering, we now come to the third core or evergreen branch, electrical engineering. I'm standing here at the electrical machines lab. Now, all kinds of machines that you might have heard of should be electrical. It's not just about the production and distribution of electricity, in which our nation needs to go much farther forward. Therefore, there is a dire need of highly qualified electrical engineers. More than that, these days you must have heard of Tesla, the car company. Electric vehicles are to be the next trend in all the nations around the world. Electric vehicles need battery, so battery technology, induction motors, after which Nikola Tesla invented the induction motors, and that's why the company has the name. Then all kinds of renewable energy, so that if saving the planet is a priority for you, then electrical engineering is something that you need to consider. Again, in several foreign countries, in older universities, we'll see that electronics comes under this branch of electrical engineering, and computer science comes under the electronics branch. So that's why in some cases we'll only discuss 3 core evergreen branches, and it ends with electrical engineering. Here, under the APJ Abdul Kalam Technological University in Kerala, there are 2 distinct branches. One is electrical and electronics engineering, and the other one is electronics and communication engineering. So if you are somebody who is interested in energy and want to do research on production of energy through various means, renewable, non-renewable, also keenly interested in working for the public sector or private sector firms that are involved in the distribution of electricity for the benefit of entire humanity, then this is the branch that you need to consider. Unfortunately, there is a lot of misconceptions these days about people that this is a tough branch, there is a lot of mathematics. All that is very unfair and unjustified. And please keep in mind that for any civil engineering project or mechanical engineering project, you do need motors and power. So you do need the service of an electrical engineer if it is any project that needs energy. And therefore, electrical engineering is the branch that energizes the world, and probably the world of the future. This will be the branch that will move the world using electric vehicles. Right behind me is a PCB printing machine. Printed circuit boards, kind of like these ones, you might be familiar. And even more complicated ones are present in this camera that is being used to shoot me, and the mobile or the computer that you are using to watch this video. Now, this PCBs brings us to the last and the latest entrant among the core engineering branches, the new evergreen branch of electronics. Actually, in several universities, computer science is considered a subsidiary of electronics, because hardware engineering, hardware configuration is equally important as software engineering, which is what mostly in India we understand by computer science. Now, electronics has changed the way we live, especially in the last 30-40 years. Electronic equipments are everywhere. And as you might know, we have entered the 4th industrial revolution. The first one was powered by steam, the second by electricity, petrol came then, and now with renewable energy, we are looking at a world of big data. And this big data is being collected by Internet of Things. All the devices around us are being connected, and this connectivity and communication, including the social media with which you must be so familiar, are all products of electronics. So once you enter this exciting branch, you will not only be looking at a worldwide possibility of career, but also to invent and innovate